Alright, so welcome to topic 2.2, which is the bonding between atoms. So in particular, we're going through metallic bonding today, just so we can cut down the length of these videos. So a little recap on metallic bonds. So in a metallic bond, we're going to have all of these metal atoms, and they're going to let go of their valence electrons. Okay, so these valence electrons then become delocalized electrons, which means they're not localized to one particular atom. Okay, so they can go wherever they want. And now that we've lost these electrons from each atom, they now become cations. So they're now positive. Alright, so we have our metal cations, and they are swimming in a sea of delocalized electrons, which are able to move freely. Alright, so our properties of metals. So our first one is them being lustrous or shiny. So this is due to free electrons in metallic bonds being able to reflect light and when they're on the surface of the metal. Okay, so when light hits and there are a bunch of electrons within the surface here, they're able to reflect that light back in the same direction. Okay, so if they all hit the metal and then reflect back in the same direction, then that's going to create that shining effect. If we have a rough metal, light will hit it and then be diffused. Alright, so diffused just means go in different directions, and that wouldn't be very shiny to look at. Okay, so this may require the metal to be polished in order to create a smooth surface to allow for specular reflection. Our next metallic property is the conduction of heat. So this again is due to our free electrons. So when heat is applied to the metal, our free electrons increase in energy, which makes them move a lot faster, and they rapidly move throughout the metal, transferring heat as they collide with other particles. So if we have our metal cations here, they're all not going to move, they're just going to vibrate, and they will transfer some heat with that vibration, but really it's mainly our electrons which are going to get really hot and travel really fast and start just hitting the other atoms. Okay, so it's going to transfer the heat very fast because these electrons are able to just move and hit atoms randomly. All right, and our third one is the conduction of electricity. So this again is because of our free electrons. So when an electric field is applied, electrons will be attracted to the positive end, creating a stream of electrons. Okay, this is also called an electron current or an electricity current. So what happens here is when we hook this up to a circuit, we can have one positive side and one negative side. And obviously our electrons are going to be attracted to our positive end. Okay, because positive and negative attract. Alright, so we just get electrons going through the metal. Our cation is going to stay in the same place, and our electrons are just going to move. Alright, and fourth, we have malleability and ductility, or being ductile. Okay, so the non-directional free-flowing nature of the metallic bonds mean that the atoms can be shaped. Alright, so non-directional meaning that each one of these electrons is going to be attracting in all directions. Each one of these cations are going to be attracting electrons in all directions, okay? So they're non-directional and it's free-flowing because this electron can be in any side of this cation and they're still going to be attracted. So they can be shaped, so this means they can be hammered, bent, rolled, so that's our malleability, and also be drawn into wires, which is our ductility. So ductility, or being ductile, is just the ability to be drawn into wires. And this can be done without disrupting the forces between the positive cations and the negative sea of electrons. And lastly, we have density and hardness. Okay, so since the metallic lattices are closely packed, and so density and hardness is going to be relatively high. Okay, so since we just have these big metal cations and these little electrons, our metal cations are going to be able to get as close to each other as possible. Okay, so this is probably going to be surrounded by electrons, and then our cations are going to push right up next to it to try and get as close to those electrons as possible. So they're going to both try and get really close. And that'll make it really dense and also really hard. Thank you.